In the mid-20th century, the path to space was defined by brute force engineering. Reaching the moon required staggering multi-billion-dollar budgets and gigantic, gas-guzzling superrockets. The Americans and the Soviets dominated this era by relying on sheer financial power and vast teams of specialized engineers. These early missions led to a global consensus. The moon was a dead world, a completely dry rock with no atmosphere and no water. By the early 2000s, the scientific community viewed lunar exploration as a closed chapter. It was widely assumed that the most significant discoveries had already been made. But the scientists at the Indian Space Research Organization proposed a different theory. They believed that water ice might be trapped inside the permanently shadowed craters of the moon's south pole. To prove it, they planned their first lunar mission, Chandrayaan-1. But ISRO faced a massive constraint. Their entire budget was roughly 386 crore rupees. This chart shows how that budget compares to other projects. It was significantly less than what Hollywood spends to produce a fictional movie about space, and only a fraction of what NASA spent on the Apollo program. Since they couldn't afford to build an Apollo-style super rocket, ISRO had to rely on a different approach known as frugal engineering. In October 2008, Chandrayaan-1 launched aboard the PSLV. While the PSLV is highly reliable, it is a relatively small rocket. It lacks the raw thrust to shoot a payload in a straight line toward the moon. To solve this, ISRO engineers used an orbital slingshot maneuver. The spacecraft circled the Earth, firing its engines at specific intervals to stretch its orbit into wider and wider loops. This allowed the probe to use Earth's own gravity to build momentum. Finally, the spacecraft reached escape velocity and snapped out of Earth's gravitational pull, shooting toward the moon. By trading time for physics, ISRO effectively replaced thousands of gallons of expensive fuel with the free energy of gravity. By November, Chandrayaan-1 successfully entered lunar orbit. It carried 11 scientific instruments from space agencies around the world. The next challenge was the surface. Gently landing a delicate rover on the moon requires incredibly expensive soft landing technology. ISRO's alternative was much simpler: the Moon Impact Probe. This was a device designed for a deliberate, high-speed crash rather than a soft landing. The probe detached and plummeted into the Shackleton crater, kicking up a massive cloud of subsurface dust upon impact. During its descent, the probe and the orbiter above simultaneously analyzed the composition of the dust cloud. By replacing a billion-dollar landing system with a strategic crash, ISRO was able to access deep soil data at a fraction of the usual cost. On Earth, scientists began poring over the telemetry and atmospheric data captured during the impact. This chart shows the light absorption signatures from the dust cloud. By looking at which specific wavelengths of light were absorbed, scientists can identify the cloud's chemical makeup. These dips were the exact chemical signatures for hydroxyl and water molecules trapped in the lunar soil. In a single mission, ISRO dismantled decades of scientific consensus, proving conclusively that the moon was hiding vast reserves of water. This discovery changes the future of human spaceflight. Because water is present, permanent lunar colonization is no longer just a theory. It is a realistic objective. Water can be broken down to create breathable oxygen and raw rocket fuel right on the surface, providing the resources needed for long-term survival. Chandrayaan-1 remains one of the most vital scientific milestones of the 21st century. It proved that achieving the impossible in deep space doesn't require the largest budget. It requires the will to look where everyone else stopped looking.